welcome to the Database Check Before Hardware Purchase webinar. It's with xByte Technologies and Soaring Eagle. My name is Ryan Brown. I work with xByte Technologies. And for anyone who doesn't already know xByte and not familiar with us, we're one of the largest resellers of Dell equipment out there. We've been in business for about 15 years. We sell anything from the servers to the parts, storage arrays, network switches, software. As this image tells you, really, we do it all the current generation Dell equipment and accessories parts to even the oldest stuff, to 7, 8 years old. So we really are out there to try and match customers' needs with really the right equipment. So it's not just whatever's out there right now. And so you may be thinking to yourself, why is a company that's a reseller that's really into the hardware piece of it, why are they inviting you and why are they involved in a webinar around getting you not to buy servers and equipment? Well, the reason for that is that we're really much more into solutions than anything else. We want to find, as I talked about a second ago, the right fit for hardware. And if it's not hardware, maybe it's just the fact you need to tune your database. So we want to find that perfect solution for you, and that's why we've partnered with Soaring Eagle to present this webinar, is really to help customers come up with that best solution. And I'm extremely excited to be working with Jeff Garbus. If you happen to not know who Jeff is, I don't need to read this full bio, but he is the man with SQL and with databases in general, with Sybase. I was told earlier today that this bio is a little bit off. It says 17 books, but apparently he's finished his 19th already. So he's constantly writing. He has been invited to speak and train at Redmond at Microsoft's facility. So they invite him to come there. He's also a regular speaker at SQL Saturdays. So without further ado, I'd like to pass it off to Jeff to take it from here.
Sure. Thank you very much. And if you give me, actually, it's beautiful. On to the next slide. Good afternoon. My name is Jeff Garbus. Thank you for spending the next hour with me. This will be a live tuning event, and I will invite everybody to ask questions, but I'm going to ask you to put it into the chat window or the questions window off on your right so that we can address them all at once and at the end instead of all up front. Soaring Eagle Consulting, that's my company, our company. We are a database consulting company, and basically we're a collection of database geeks. We do everything from short-term consulting, hey, we've got a performance issue or our system is down, to long-term remote managed services. As it says in the slides, we also have a suite of training classes. For a long time, we had a full suite of training classes which did compete with the normal Microsoft curriculum, except that it was geared more toward the practical use of things rather than the certification process. Now we have one class that we present. It is basically a performance and tuning class for developers, although DBAs have enjoyed that as well. The remote services, just as it sounds, remote database managed services. If you've got one DBA and need 3, or if you have one that needs vacations, or you simply can't find anybody with the skill set you need, that's us. We also resell some performance and monitoring related software. But at this point, what I'd like to do is stop talking about us and move directly into the tuning exercise. So if I may, Ryan, if you could please turn this back over to Alan and get me the controls. I'd love to get started.
Sure thing, Jeff. I'm just going to pass it over to Alan. Then Alan, if you can give Jeff controls. You also need to share your screen with everybody.
Jeff, do you have control?
Okay, Alan, I see a blank screen. If you could please bring up Ignite and then pass me control, that would be outstanding.
Okay. Is it up?
I still see only a blank screen, a desktop.
Well,
There we go.
Oh.
Excellent.
Okay.
Houston, we've landed. Beautiful. Now, if I could get the control, and it looks like I've got it. Beautiful. Thank you. Okay, everybody, we are back in action. This is the tool that we tend to use. While we resell the tool, this is not a seminar about the tool, so I'm just simply going to move into specific tuning types of activities. Now, what Alan has done for us is set up monitoring on 5 of the SQL boxes and given us permission to go in and identify what it's doing and simply have a little bit of fun with it. As we're looking at these wait states, I am going to, usually I'd start with 17, but we did a quick check last week, and I'm going to go back into 17 just because I know there's some interesting things to find in there. Now, as you're looking at this type of tool, what this type of tool does is measure wait states. So this is user experience. So when you ask, what is the performance? Is the performance good? What do your users think the performance is? This is what the user thinks of your performance. So let's get more specific. If, for example, you're saying select star from a table and you're bringing a million rows of data back, well, you got some amount of time that's going to be spent bringing the data off the disk. You're going to have some amount of time that the data is going to be sending across the network. And that really is where a lot of your lapsed time is going to be. It's going to be network time and disk time. Not a lot of time spent in the CPU because the CPU really isn't doing anything except queuing up the I/O subsystem and the network. Now let's take a different type of activity. Let's say that you are running a Cartesian product. Well, at that point you're bringing lots of data into cache, you've got lots of CPU spinning, and you're using lots of CPU. Final type of thing that you'll see a lot of is locking and blocking. Well, in a database environment, locking and blocking are normal, but if they happen for more than, a fraction of a second, people start to get upset and they say things are slow. Now, it does not necessarily mean that what they're doing is slow, but their perception is that things are slow because they're waiting for other things to complete before their processes can move forward. So that is what we're seeing here. What we're seeing here is on July 2nd, 70 hours worth of activity. Now, most of you are doing the math and saying, gee, Jeff, aren't there 24 hours in a day? How can there be 70 hours of activity? But from a practical standpoint, if I've got 1,000 users who are all waiting for 5 minutes, that's 5,000 minutes of wait time that's captured over the course of a 5-minute time period. So this is not necessarily everything the server is experiencing linearly. This is the aggregation of all the work and all the experience that the users are seeing. So this being a busy day, I'm going to jump out to, this is 11. This isn't 9 or 7. I thought we were going to 7 first. I guess I messed that one up. But let's just stay here because it's fine. No, 11 was the one. 17 was the other. So let's stay with this one. What we're seeing here is over the course of this time period, 10 a.m. is really busy. Now, I'm going to come off of this graph just for a few minutes because when I'm doing a tuning exercise, the first thing I look for is what's going on right now with the physical resources. So, for example, if the disk is spinning out of control and I've got disk queue links that are spinning out, well, it may be that we need to start looking at faster disk if, in fact, we can't reduce the amount of work that's being performed. But I'd like to see where the limits are, what the server thinks the stress points are, and that's kind of where we're looking here. So I'm going to change this perspective from last hour to last 24 hours. Usually this brings me up to CPU first, but it identified some memory issues, so let's take a look at what's going on with memory. The first chart is page life expectancy. Page life expectancy means how long do we expect a page of data. Data obviously in databases are stored not really in rows, they're stored on pages. So that page is a collection of rows. The page is the physical manifestation of your logical concept of a row of data. So what are these pages doing? Well, the page comes into memory and it will stay there until it gets pushed out. So as we're looking at page life expectancy, I like to see the page life expectancy up here in this 5-figure range. So 20 to 50,000 seconds is an awesome page life expectancy. But we're seeing that that page life expectancy crashes here in the 1 o'clock to 2 o'clock time frame. And I'll explore that later, but I'd be willing to bet that's when a lot of the maintenance is going on, the backups, the DBCCs, the index rebuilds, because those will mess it up. But it sure looks like during standard operating hours, the page life expectancy is really good. The next graph is the OS memory utilization. Now, if you take a look at the documentation that Microsoft has, Microsoft will say something like, you should only let the database use 65 to 75% of the available memory. Well, that's an extremely specific recommendation. Unfortunately, that's not a great recommendation to make cold. So let's say, for example, you've got 100 gigabytes of RAM. Well, do you want to just give the database 65 to 75% of that? Does the operating system really need 25 to 35 gig of RAM? Optimally, it does not. What you'll find generally is that if you give the operating system 4 to 8 gig, that's more than plenty. So as you start increasing the amount of memory, that particular rule of thumb becomes less relevant. Now, when we're looking at this and we're seeing that the memory utilization here is up in the, let's see if we can get the mouse to pick up a value, 95% range, what I will do is go out to the physical server and ask the question, how much memory is on the box, and have we limited the amount of space available in memory, the amount of memory available to the SQL Server? Now, I'd be willing to bet that if we went out and looked at this, we'd find that the SQL Server is configured to use as much memory as it wants. Alan, do you happen to know how much memory is on this box and whether it's limited?
Yes, the amount of memory on the box is 32 gigs, and it should be set for max memory at 30 gigs, leaving 2 for the OS.
Oh, so 30 and 32. So that's probably a little bit tight. So one of the things I do suggest is you leave at least 4 for the OS, and you can put that down as my first formal recommendation. Scrolling down, the other thing that I like to look at is the memory paging rate. The memory paging rate is something that basically it means that the operating system does not have enough space for memory and it's paging it out. So that's an extremely inefficient type of thing. Again, we see this during what I expect is going to turn out to be some overnight processing. With only 2 gig of RAM available, that's probably why this has got a memory paging rate that's growing like crazy. Because we have such a good page life expectancy, what I would do, again, if I'm monitoring this and managing it, what I would do is increase it from 2 gig to 4 gig available for the OS. And watch this, because sometimes this can cause things to get slower and slower, especially as you start to scale and things start to grow, and see if these numbers come down. You can do that easily if you have a tool like this by clicking on the 1 week and comparing day to day. So it looks like that's what we've got going on. Log flushes are staying low, compilations and recompilations are staying low. Those are all very good numbers. I'm going to slip over here to the CPU. We're still on last 24 hours. Signal weights is below 25% pretty consistently. If you're running in a VM environment and you're finding that these are bouncing up a lot, that's a very frequent thing. And it has to do with a feature. I call it a feature, not a bug, because it's documented in a variety of places, where if you're running in parallel, then you cannot grab the process will not run until it has all the parallel processes it needs. So, for example, if it wants to run with 4 parallel threads and it can only get 3, it'll wait for that 4th. And so, even though these CPU queue lengths tend not to show up, you'll sometimes see signal waits when you don't have the CPU queue lengths. And in a VMware environment, it frequently means you need to scale back your parallelism. The instance and the operating system are using very little CPU, which is a good sign. So let's see what else is going on. This means we have plenty of room on the box, at least as far as the CPU is concerned. Now, I'm going to go back to trends, and I'm going to go back to the day that looked really busy and see if we can figure out what was so busy about the day. Well, most of the day is kind of quiet, but in that 10 o'clock to 11 o'clock time period, something's performing a lot of activity. What's performing all the activity? Well, it looks like this process is experiencing a long elapsed time. What is it doing over the course of this? Looks like 45 hours of wait time. Well, the blue color is telling us that it's lock wait. I can find out that that's lock wait by clicking here, but I happen to know that this LCKMU is an update lock that it's trying to get hold of. And what this means is that it's being blocked. So this process is not actually running and executing. This process is actually sitting there waiting for things to happen. So even though it's performing a couple million logical reads, that should be some number of seconds of elapsed time and not some number of hours of elapsed time. So let's see if we can figure out what it is. And by the way, we can take a look at this. We can also find out things like what database is this running in. Here's the name of the database, what program is running this, and it turns out it is this Stingray KNI executable. But most interesting, what I want to do is look at the blockers, because generally when we have a blocker like that, it's one of a few things. This particular blocker caused 25,000 seconds of blocking time, manifested over, well, a lot of these things are being blocked for 10 minutes or more. So as we ask the question, what's doing the blocking, what we'll do is we'll come over here to where it says details. And what this will tell us is that this process was doing the blocking. So it looks like we have one update blocking another. So these particular updates seem to be having a snowballing effect where they're blocking one another. What I would suggest is, it looks like a very simple block, or a very simple lock. Alan, I don't remember if you agreed to it. Can we take a look at Management Studio so that we can take a look at the indexing for this? Or would you rather not do that live during the webinar?
Michael Junisek? Are you still on, Michael?
Okay, well, let's get past it then. I don't want to do anything live that's going to raise a ruckus, but what we want to do is take a look at this table, the AM policy quote table, and make sure that there is an index on the APQ locked session column. The most likely cause of this entire blocking is that it's doing table scans and blocking the table for the duration of the updates, and that all the other updates are piling up behind it. So make sure that we have an index specifically on this column. Also make sure that, because it thinks that we're passing in a varchar, make sure that the data type matches. So make sure that lock session is actually a varchar 32. If it's not, then that's something that you want to fix. This is something I see with some degree of frequency, that we get a bad query plan or a bad blocking approach because of a data type mismatch here. So let's move past this one and see what else there is to find. What I'd like to do now is I'm going to come back to the home screen, and I'm going to come back to MS SQL Live 17, simply because this is telling me it's the one with the most weight, so it's probably got the most activity on it. Ellen, by the way, if you'd like me to pick any particular other server or any particular day or time of day, please just shout out and drive me there. I am very flexible in terms of what we're going to work on and look at. So what this is doing is it's showing me what's going on today. Here's today on server MP SQL Live. Down here in the Resources tab, as I scroll up, what I can do is I can look at a few things. First, I can see what the activity is. So I see a lot of activity in the 3, 4, 5 o'clock time range. We'll take a quick look at that in a few minutes. I can also take a look and see what the other resources is doing. So once again, this is a different server, so I want to look at the resources. The round trip times are fine, anything under than 1 second. This is basically a ping of the DBMS. So from the DPA server, I'm pinging the DBMS and asking how long does it take to get something back. And if these are in the same cabinet or even the same colo center, that's typically down in the 0 range. If you're pointing to a virtual machine, so my guess is these boxes are running standalone and not virtual, you tend to get about 1 millisecond of round trip time, which seems to be the overhead coming into and out of a virtual machine. CPU is, again, really low, not using very much at all. The memory paging rate, we've got a couple of spikes, but otherwise absolutely fine. The disk queue lengths, no I/O issues to speak of on this particular box. So the first thing I'm going to do is look at this 3 a.m. time frame and test my assumption that this is nightly maintenance, because that may or may not be true. What I'm seeing here is that it's all memory related. So whatever is going on, it's chewing up CPU. What is the activity? Let's take the first one and start from the top. And this is we'll take a look at that in just a second. This is run 2,000 times over this time period for a total of about 70 million logical reads. So one of the things we do when we're tuning is ask ourselves the question, do we get value from tuning this particular activity? So if something's running once a month, it's running at night, and everybody's sleeping while it runs, probably not worth taking 5 days to tune. On the other hand, if it's running a few thousand times an hour and chewing up a lot of resources on the box, and as we saw, we're using the CPU very heavily, then that's probably a good thing to tune. So as we're looking at this, let's ask what resources we're using. Well, 2,000 executions at 70 million page requests, we have about 35,000 page reads per execution of this query. Now, if that's a one-off, then I tend not to worry about 35,000 executions. But when the totals are up here in the tens of millions of range, that tends to be worth the effort. So once again, we take a look at the query, and were we doing this live, what I would do is I would take this entire query and I would pop that right into a Management Studio window. Up here where I have P1 and P2, I would put a declare in front of it, right-click, do an estimated query plan, and see sometimes without even doing any work, you get a recommendation back from Management Studio saying something along the lines of, well, if you add this index, this is about to get 90% faster, which is kind of a no-brainer. If I can knock 70 million page requests down to 7 million page requests, that's a big win. At which point I'll add the index and then run it again. If not, what I'll do is I'll spend some time mapping out the individual query. By mapping out the individual query, what that means is that I'm going to ask the question, which table do I generally want to join from? Now, for those of you who don't work with joins a lot or don't work with indexes a lot, up on our website, actually up on our YouTube channel, I have a couple of great presentations on indexing for performance and indexing joins for performance, and I do recommend those very highly because they talk about the differences between clustered and non-clustered and what's going to speed the joins up. But in general, what the server is going to do is pick a starting table for the join, then join to the next table, then on to the next table. How will it decide? Well, it will generally pick the one that has the most restrictive where clause. So if I'm joining from table A to table B to table C, then I'll look at the where clause and say, it looks like I'm restricting on this A dot, this A table. So whatever we have as A from HO premium as A, this is generally going to be where we start. Now, it looks like this is a function call. So if we have a table-based function, one of the things I'm going to recommend is that we take another look at that. The problem with the table-based function is that we have to resolve the entire table-based function before starting the join. So what we would really want to do optimally is pass these values into that table-based function so that we're only bringing back those rows that we actually want to access, or more specifically, let's, if we have to, create a separate table-based function just for this query and speed things up, or take whatever is going on in that table-based function and bring it back in. So my guess is we'll probably bring back a lot more from that function that we're working with because we're putting the where clause here, and that may be a big part of the logical reads. So I guess next recommendation is to take this particular query and tune it. If you want, I can label this just so that it's easier to find, table-based function. So when you're trying to find this particular one, what you're able to do is take a look and say, that's the one Jeff talked about, so we can go over there, click on it, find out what it is. So I'm going to click on the next two, just coming down the line, and it looks like these are similar types of activities. So if a lot of these things which look similar, running a couple thousand times an hour, performing 60 to 70 million IOs. Every once in a while, and again, same sort of numbers. One of the questions I often get is, hey Jeff, we've got this batch process that runs overnight, and it fits within our window. It's an 8-hour window, and it's only running for 4 or 5 hours, but a year ago it ran for 1 hour, now it's 4 or 5 hours. How long is it going to take a year from now? We need to start looking at this in advance, and that's something that I do like to do, is get a head start on these types of things. So again, my recommendation, take a look at that table valued function, only bring back the data that you care about. Also, make sure that you have good join criteria. So if we're joining from A to B on these criteria, make sure that in the B table, for example, you have an index on this SPTRN ID and SPTRN trans type. You want to make sure that's a compound index on ID first and then trans type. And then down here on the WP table, make sure as you're joining to WP, you have an index on the combination of WP record ID and WP premium name. Again, you want that to be a compound index on the record ID first and the premium name second. So I'm just going to work my way down this, just one or two more. Looks like we've got a lot of consistency here in terms of what's going on at this time of day. So we've taken a look at 3 to 4 a.m. Let's take a look at the 4 to 5 a.m. time period. Looks like similar type of activity, so I'm going to consider this one addressed, not resolved, but addressed, and start looking for a different subset of problems. So that's what's going on overnight. Let's go find out what's going on today. And this is interesting because it's now in this current time period, and we see a graphic which, I mean, really, the expression is the nail that's sticking up is the one that gets hammered. And from a practical standpoint, for me, these things that are jumping out are the low-hanging fruit from a tuning perspective. So if these all look similar in terms of, okay, this much green, which is that table-valued function, and this much red, which is this particular function, what I want to do next is ask the question, are there any anomalies? And to me, this is definitely an anomaly. So let's take a look at this time period and see what's going on here. Well, the first thing that I see going on is a query that's different from what we've looked at before. 33 executions, 80 million page requests, and this is doing a lookup on the policy search table. So as I'm looking at this, my guess is we're doing table scans. We may be able to run some query analysis, but I don't, when I do things like run query analysis and go live plan, I may be hitting the live data, and I don't want to hit anybody's live data directly without talking to them and making sure that's okay. But I can ask other questions. Now, the first thing that I noticed was that this seemed unusual. So is this running a lot? I can take a look at the historical charts and find out whether this runs every day or only sometimes. And it looks like it doesn't run an awful lot today. So hundreds of times per day, and we don't even have a high utilization on it. So I'm kind of wondering why it's spending all of its time doing that. So let's go back and take a look at it. 80 million page reads, so lots going on. So what I'm going to do, again, if I'm doing this as an on-site tuning exercise, what I want to do is make sure there's an index on policy search, and I want that to be on the combination of code, current record, and slob ID. I'm sure that's S-Lodge Object ID, but it's so much more fun to say slob ID. What order am I going to want to do these in? Well, when I index, and again, I want this to be a compound index on the three of those, I want to be on the most unique column. So what's most unique? Well, that would be a question for either Alan or Michael or one of the group over there. Or I could go in and I can take a look and say select count distinct on each of these columns. Now that may not be something you want to do in your production environment if you've got hundreds of millions of rows of data, but maybe you can go ahead and do that if you say with no lock. Maybe you can do that in your development environment, if in fact you don't already have a handle on the granularity of your data. So once again, probably an index selection, especially since we're just looking at the top, select distinct top 20. So that may be a little bit different in terms of execution, but this still looks like a huge number of logical reads and likely some table scans to pick that up. If this is like a typical Microsoft design, there's probably an index on something like a policy search ID, and or is this a table or a view? Alan, do you know off the top of your head?
No, I'm sorry, I don't know.
Yeah, no problem. So when I look at these, sometimes it turns out there are
this
views.
This is Michael. Yeah, this is actually view.
It's a view. Okay, so what we need to do is take the view and make sure that these values are good for the view and that the view has a good join. So once again, I'm just going to go ahead and label this as something to come back and take a look at. And I'm not changing anything in your production system, guys. All I'm doing is labeling these things in the tool to make them easier to come back and find. So note that that took an unusual amount of time. Maybe it's got different parameters that are being passed today. Maybe there's some unusual activity today. One of the other things that's nice to look at in a tool like this is I know where all my time is being spent. These top three, maybe the fourth query as well, but I know where to start tuning and I know what the nails are that need it. So once again, it's a policy search issue, so I'm just going to come back and look to see what the third one is. And it is, once more, that select from policy search. So this is an area where we need to go take a look, make sure we've got good join criteria for the view, and also make sure that we've got a good index. So whatever code is in, make sure that that is a good indexed column for this particular lookup. And what's this one? Same one. Okay, so we've taken a quick look at those. And we've taken a look at the colors. Note that these colors will not necessarily be consistent. The other colors for the weight types will be consistent. So this policy search and this table valued function, these are all things that you might want to go and take a look at. So that said, let's take a look at things from yet a different perspective. I'm going to go ask the question, what's going on right now? So when I ask the question, what's going on right now, I'm going to come over here to the current tab, and there are a variety of interesting questions that we can ask. So we can see that in the last 20 minutes, we've been dramatically busier than we were when a lot of people were at lunch. Another thing we can take a look at is rather than, okay, these are those 3 busy queries, which we've already looked at, what are really the longest running queries? This becomes really interesting to me because I can say, policy search running at 26 seconds. These are also similar to policy searches. Here we've got another one running at 14 seconds. And so even though they're not bubbling up to the top of the other list, what I can do is take a look at these individual queries and ask the question, if they're running for a while, do I care about this? Now, why would I do something like this? I'm going to come off the current tab and back to the trends tab. For a minute. I'm going to come back into July 9th, and I'm going to come back into, I'm going to go to the 12 p.m. instead of the 1 where I had the anomaly. Sometimes the question is not, do I have consistent performance on the box? Sometimes the problem is, well, the CEO of the company is calling me up and saying things are slow, fix it. Well, one of the things you want to be able to do is ask, what is he doing or what is she doing? We may want to come in and ask the question, if it's coming from a particular user, what is the user doing? so we can drive this from a per user perspective. And honestly, this is not an unreasonable way to do your tuning. Are you tuning for the person who is having the biggest impact on the company, namely the person who writes your paycheck, or is it for the person out in accounting who is holding up your expense check because you lost a $4 lunch receipt? And yes, that one has come from examples. So we can do this on a per user basis, and we have a variety of ways of drilling down. I'm going to come back to the current tab. I like that long-running query. We talked about that. We looked at it briefly. The other one I like here is this most executed tab. This gets really interesting because sometimes it's not the query that you think is running a lot that's having the biggest load on the box. Sometimes it's something small. I have a fond memory of talking to somebody about that while installing a monitor, and the person saying to me very clearly, "Jeff, that's not going on here." And then we found that this one query that was taking only 80 milliseconds to run was taking up 35% of the CPU. Well, we took that 80 millisecond query and tuned it down to 0.2 milliseconds, and guess what? They got back 35% of their box, and they put off a hardware purchase for 2 years. Sorry, xByte. But the flip side is if they're more profitable, that's sort of a tongue-in-cheek, sorry, xByte, because I know that's why you guys brought us in.
I know.
The flip side is, I'm sorry, go ahead.
Oh,
Yeah,
I was making a funny comment. It's fine.
Okay, cool. Flip side is if you're more profitable and you're getting more out of your hardware, your company is going to grow. You're going to be more profitable, and you're going to have more money to spend on the hardware later. So as I'm looking at this, if it's running 11,000 times an hour, even if it's not bubbling up in that top 10 queries, it's often worth exploring and asking the question, how often is it running? Is it running more particular days? Looks like it's not running over the weekends, or at least not on a holiday. Looks like it is running in the 20 to 70 or 80,000 times per day range. So I can get these frequencies out of here, and once again, if it's running a lot, it's worth tuning. Now, as I scroll down to a slide like this, this becomes really interesting to me. Reason this particular box is interesting to me is as follows. If I'm running 10,000 times today and 20,000 times tomorrow, what is my expected execution time or return time per execution? Well, if when I'm running 10,000 times, I get on the average, 0.136 milliseconds, and then when I'm running 70,000 times, I'm running on the average 1 millisecond. What that tells me is that I'm not that scalable. It tells me that as I increase the number of executions, the execution time goes up. This is a negative indicator for scalability. So a lot of times I'll get called in and people will say, we're about to triple the number of users, what's going to happen? This is a great place to look at that effect. So as you're taking a look at your critical stored procedures, watch to see what happens between this graph, the number of executions, and the execution time. Interestingly, here we had fewest executions and one of the higher execution times. How do we explain that? Well, we can go back and take a look. So lots of fun stuff built in there. Here's the query. Select from system temp var or session ID. So hopefully there's an index in the system temp var table on the session ID column. And it may just simply be that memory was getting crushed at the time that this was running, and it was taking a full millisecond instead of a tenth of a millisecond to run. So I'm going to go back once more. So that was the most executed. Fun thing to look at, because this gives us the ability to find out specifically where these things are coming from and what's taking up a lot of the resources and what's running a lot. Storage I/O. These days, I don't always get to spend a lot of time here, or I don't always bother spending a lot of time here, and here's the reason. Most folks these days buy a SAN, and they simply point everything to the SAN. They put everything on the SAN. So then the question becomes, is my SAN running sufficiently fast? Well, the answer to that is relatively easy. We go and take a look at the disk queue lengths. If the disk queue lengths are running sufficiently fast, then we will say, yeah, no disk queue lengths. No problem with I/O. Now, at that point, we don't worry about that. The other problem we run into is what happens when the disk queue lengths start to climb. what we need to be able to do is come out here and ask which of these individual areas have the biggest disk queue lengths, and what do we need to worry about there, and where are they, and how much is the elapsed time, and what's the wait time. If I were to pick the top few things that I tend to have to deal with the most, I would say adding indexes is something I do the most. Fixing code which is non-optimal is something I do second most. And looking at hardware constraints is really probably down at the 5% range, but probably the third most. And in particular, people asking, Jeff, what do I do about my I.O. issue? And it's, well, you can spread the I.O. out, you can request fewer rows, or you can get faster I.O. There doesn't seem to be any additional options. So it's about 2:45. I'm going to spend a few minutes. I'm going to bounce over to a different server just to take a fresh look at something different, and then I am going to open this up for questions. Hopefully you've had a little bit of fun and have learned a little bit and have had me point to some things that you've had some fun with. Here we've got some red, so I'm going to jump into this particular server. And I'm going to start over here on the Resources tab, the one with the exclamation point. And once again, we've got the memory that's bouncing up, and we're seeing this at 96% of memory. And again, if this is 96% of 100 gig, probably not a big deal, but at 96% of 36 gig, might want to give a little bit more to the OS, even though we're not seeing a huge amount of stress. We did see a big memory paging jump in this time range, but a single point I would consider to be an aberration. The page life expectancy seems very reasonable. So even though this alert is coming in high, and even though I would make that adjustment, I wouldn't expect to see any huge results of the adjustment, but I would be expect less to see this type of spike later, which can sometimes cause I/O spikes in and of themselves. So let's take a look at this trend where I've got another exclamation point. And I'm going to come in today and ask the question, what's going on right now? Well, again, just looking at the graph, we can see that there are a few basic queries that seem to be doing a lot of the work. So let's take a quick look and see what they are and what they're doing. The first one is all memory. Let's take a look at this one first. 256 executions, 1 billion logical reads. From my perspective, this one is a good one to look at. By the way, my personal record, I do these types of 1-hour reviews on a fairly regular basis, rarely live like this. Thank you again, Allen & Company, for allowing us to do this. My personal record is taking one of these that was performing 100 billion IOs an hour, logical reads, and taking that during the hour down to 3,000 from 100 billion. Because they were missing an index, and we took their 10-minute response time down to sub-second. But that was a very unusual situation. But looking at this, let's take a quick look. This is 256 executions, so we're talking 40 million page requests per execution if my post-lunch math is still good. Select case from workflow notes where okay, we have an or in the join clause, which is a little bit unusual. Or is this even a join clause? Are we going after just one table where it's in? We may just need to add some indexes to this list. So it may be that workflow notes does not have an index on user IDs. Note that with an or, we talked before about the ands and the need to add a compound index. With the OR, we need multiple indexes. So I want an index on SUser ID. I also want an index on HWF personal user ID. I also want an index on SRL ID. So all of these things need to be indexed, and we need to double check those. And make sure that these types of things are included. Now, putting the isnulls here in front of the code usually makes the server not use an index. So what you might want to do is take these isnulls out and adjust the dates in the code prior to passing them into the query. That may speed things up as well. So I'm just going to make a note to address this query. billion page requests per hour. I misspelled billion, but you can fix that if it becomes important to you. Let's take a look at the next one. We identified that there were 3 that were really busy. Now this one is spending its time between CX packet and page latch. So let's explain that one a little bit more explicitly. CX packet wait means we're running in parallel and we're waiting for the packets to get rebuilt before sending them back. So there's different ways of running in parallel. One way of running in parallel is we have 6 different processes, and then as the processes bring data back, they fill up these network packets like buckets. When the network packets get filled up, they get shipped to the client. The other type is when we have to do something after we assemble the data. So for example, I've got 6 processes, but before I send it back to the user, I have to sort it because there's an order by. Now at that point, what I need to do is make sure that the order is done, and that's what the CX packet tends to mean. May also be an indicator that you could add an order by. But this over here, this page latch wait, is usually a memory or I/O wait. So these are indicators that we're trying to get information into memory. If we take a look at this, the official definition is trying to synchronize the buffer structures, which means getting the information off of the disk and into memory. Now this can be a memory-only thing if, for example, we're touching a lot of these and need to rearrange a lot of the pages while those pages are in memory. So we'll take a quick look at these. Select count star. 6 executions, 21 million page reads. Note that left joins are something you need to be aware of. When you start doing a left join, most joins are inner joins. You join table A to table B, here's the criteria, server bring me the results back. When we do a left join, 2 things happen. First is we are making sure that the table on the one side of the equation is always bringing back all the rows, whether or not they meet the criteria of the join. But the other thing that's happening is that when we're doing that left join, or right join for that matter, we're forcing a particular join order. So if you've never had this experience, what will happen sometimes is you join table A to table B, the performance is great. Then somebody says, hey, by the way, you need to bring back all those rows on the other side regardless because we're doing a report. You say, I can do that, and you change it to a left join or a right join, at which point the performance goes into the toilet. Well, generally the reason for that is you've changed the join order, and there's an index matching the join order in one direction but not in the other. When that happens, well, it's time to go back and add another index to the table that perhaps you weren't expecting because you weren't joining to that one earlier. And let's take a look at the third one. Another select count star, 6 executions, 21 million logic reads. My guess is something similar.